Hello everyone, thank you for joining this webinar or demonstration of the Deconvolution Wizard in Huygens. My name is Wouter van Weerenonk and today I will show you some of the changes we made in the Deconvolution Wizard. The biggest change is that we added a new parameter for the regularization of the deconvolution result. This parameter was already incorporated in the Deconvolution Express tool to do fully automated deconvolution without any interaction with the user. From now on it will be also possible to get identical results with the Deconvolution Wizard while still being able to change parameters if you would like to do so. The parameters can then, as usual, be stored in a deconvolution parameter template to use in the workflow processor to deconvolve in batch mode. First I want to give you a short overview about some of the parameters involved when you do deconvolution. So we normally take an acquired image, you load it in the Huygens software, and then from the metadata that is stored with it we can create a theoretical PSF, basically the building stone of your image. And then to do the deconvolution, very simply said, we divide the acquired image with its PSF to get the result. Of course, we also need to take into account noise that was added during the acquisition. To do the deconvolution, Huygens uses iterative algorithms to get to your results, and you as a user need to provide some stopping criteria on when deconvolution needs to stop. So that can be a maximum number of iterations, or when you set the quality threshold at such a value that the deconvolution will stop. And then as a regularization parameter, the signal to noise ratio has been used in Huygens to get to the end result. So changing the signal to noise ratio value within the deconvolution wizard smoothens or sharpens the end result. And this is a value that the user needs to give to the Huygens software, yeah, the feedback that we got is that users find it difficult to determine, okay, which signal to noise ratio should I set the signal to noise ratio value, and that's important to set it correctly. On the following slide you can see the effect of the signal to noise ratio regularization parameter on a deconvolution. Here you can see an example of a raw whitefield image, and it's two deconvolution results when using a very low or a very high SNR value before doing the deconvolution. When using a low SNR value, in this case 5 in Huygens, you basically tell the software that the raw data has very low signal and lots of noise. And this will cause Huygens to smoothen the result to make sure that to get rid of the noise and while still trying to maintain the signal present in the data. When using a high SNR value in Huygens, in this case 100, okay, you are telling the software that there is lots of signal present and low or no noise at all, and this will end up in a much sharper result. However, when you set the SNR value too high, then there is noise present in the data, then there is a chance that the algorithm creates can create artifacts like creating objects out of noise. This is because the SNR value that was entered in the Huygens is the wrong one. Something that you do not want, of course. Another side effect could be that when you put in a signal to noise ratio value which is too high, here you can see another a raw image and two deconvolution results. One was the result when setting the signal to noise ratio too high, so on the left hand side, and the other one has a more realistic signal to noise ratio value. And I needed to boost the contrast in order to see this, but in the high SNR case you can see that there is some kind of strange signal loss around the bright areas in the image, which are artifacts, because it's not realistic that suddenly signal drops down to zero in this case. So users find it difficult to determine how we should set it. So to summarize a little bit, until now in the Decon Wizard the SNR was changed manually by the user in order to smoothen or sharpen the decon result, and you could use then the Deconvolution preview button in order to see what the effect was on the image, but it was always up to the user how to do this. As users are very happy with the fully automated Decon Express tool that you can see here on the right hand side, there were lots of requests to include also these automated settings in the Decon Wizard, and that's why we have introduced the new parameters also in the Deconvolution Wizard. With one side note is that in the Decon Express tool you cannot change any parameters as a user. Everything is automatically done by the Huygens software, while in the Decon Wizard if you leave everything on default you will get identical results, except for the fact that you can still manually change parameters if you would like to do so, and then save the parameters in a template for further use in the workflow processor to do batch processing. Of course, we made these changes in the new Decon Wizard, but we made sure that results from previous templates do not change the outcome of the previous results. So we make sure that the previous results are still reproducible. So to show you how it now works in the Deconvolution Wizard, let me walk you through this updated Decon Wizard. I will close presentation, and I already had the Huygens Professional open, where I will go to the Deconvolution Wizard. The changes applied in the Huygens Professional Decon Wizards are also applied, of course, to the Decon Wizard in the Huygens Essential. So if I have this image here available, it's a spinning disk image where a HeLa cell was stained for actin filaments and a nucleus. What I will do is I will simply go to the Deconvolution Wizard. Let me put it on the maximum screen, and the first stage of the Deconvolution Wizard basically did not change. You still get your text, so with each step things are explained on what you need to do. And the first step always has been an overview of the microscopic parameters that are available for this particular image. So of course the XYZ sampling is of importance to get good deconvolution results. Things like the wavelengths are of course necessary as well, and this is merely to review the current parameters. If you have a previous deconvolution template, then you can apply that to this image with just selecting it. Otherwise, if you want to create a new one, then you just simply go to the Enter Wizard button. Then we get the usual option to load in an experimental PSF if you would have that available. Otherwise, for the deconvolution, the theoretical PSF will be created using the parameters stored with the data. Then we can click on the next button. We can crop the data if you would like to do so. So we can launch the cropper. I'll open it here, and we can crop it in X, Y, Z, or in the time dimensions. We can crop channels if you would like to do so. But for now, we will just leave it on the original, in the original size. Go to the next step. Deconvolution Wizard. Always we need to deconvolve channel by channel in order to make sure that we go through all the different parameters, so that we can check if we would like to keep them on the default settings, or maybe you would like to adapt some. So go to the next channel, and this is the first step where things have changed a little bit. We can see here automatically the image histogram showing up, and to spot, for instance, clipped voxels, saturated areas. But the Deconvolution Wizard now also made an initial survey of the data set. So in this case, the first channel. So it already gives you now the suggestion of the best deconvolution algorithm that can be used to deconvolve this data. In this case, the classic MLE algorithm is the choice to go for. It's for this image also the only one, but it can also be that in this drop-down menu that you have the other best possibilities, so that you can force Huygens to use, for instance, the quick MLE or the GMLE algorithm. But as the classic MLE is the most robust one and can be applied to any data set, so in this case we can continue to use that. Another thing that Huygens then now, what it does now is it uses the signal to noise ratio estimator to to estimate the SNR value. It also gives you a reliability factor, in this case good. So in this new Decon Wizard, we need to set the actual SNR value of this image. It is a spinning disk image, so typically the value of the SNR lies between 20 and 40. So this would be an excellent value to keep on default. If you want, you can always adapt it if you would like to do so. For wide field images, typically the SNR values vary from 40 to 60, and for confocal data sets it lies between 10 and 20, 25 maybe. So these are some estimates that you can use when checking for the SNR values. Then we have here the new mode, which is by default it is on. It's the Acuity mode. So the new parameter mode, the actual parameters will come at a later stage, but this will give you an option to use the signal to noise ratio as a value as before, so using the SNR value as a regularization parameter. But if you keep it on, then the acuity parameter will be seen as a regularization parameter. For when you have created templates in the past, then the Huygens software will check whether an acuity parameter is available in the template, yes or no. If it's not, then it will automatically, in the workflow processor, for instance, switch this off so that the previous results will come out. We are going to leave it on the setting on so that we can I can show you the new parameter in one of the next steps. This also has not changed yet, so still we have the automated background estimation in the different modes. So we can simply look for the lowest value in the whole image, which in this case, for this particular image, is the suggested ones. If we would switch it to a near object, for instance, then the Huygens software will look for the object in the image and search within a certain radius for the lowest value, which is typically higher than really the lowest value that can be found in the data set. Of course, you can also inspect it manually and just put in it yourself. For now, I'm going to put it to auto, and here it estimates, okay, that the background value that we want to use is 102. If you like, we can check that. We just slide through the image here, and using the left mouse button we can create a signal intensity profile across that line. And just by looking at the average, you can see, okay, the background is maybe a little bit higher than 102. That's up to the user to decide whether they want to increase that a bit more, yes or no. Again, the absolute background is 102. We can increase it, for instance, via 10%. Then 10% of the value is increased. Again, up to the user to decide what you would like to do. I will keep it on the default setting at the moment. So when I press accept, we get to the final stage, which also has been changed a little bit more. So we have now the maximum number of iterations. So how long does the deconvolution software need to need to go on, together with the quality threshold. We still have the default iteration mode and the brick layout like we had before, but the acuity slider is a new one. So also in this case, or in every case, the Huygens software will find an automatic setting that can be used for the deconvolution. Here you can see, and if I remove this line, so here we have the smoother and sharper slider. But for this image, by default it's set to -7. We can have a look at the deconvolution preview, and here we can have a look on the effect of the acuity, the new acuity parameter. So if I would put it to -100, it becomes a little bit more fuzzy or smoother. and if I put it to high, then you can see that it gets more sharper, and this is up to the user to decide, okay, how far you want to stretch it. Normally in the Deconvolution Express tool, this is kept on the default setting. So if you want, you can switch that back to the default setting, and you would still get a good result to do the deconvolution. So this is the new parameter that and value that will be stored in the deconvolution template, so that you can do the batch processing on lots of data. So then for the deconvolution result, we just start the deconvolution run, and then we will have the output. And then for the second channel, it's the same as for the other image. So still go back to the suggestion of the best algorithm to use, the signal to noise ratio that has been estimated, that you can keep on default or change if you would like to do so as well. You can correct it if you would like to do so. We go back to the background estimation. We'll keep it on default as well. And then in this case, the Huygens software, for the Acuity parameter value, it sets it to -77 in order to deconvolve it. So here we have the decon preview. You could again explore it yourself, but if you simply want to continue, then just press the deconvolve button, and if you want, as usual, you can restart everything if you would like to, or continue the deconvolution if you want. If you're satisfied, press the all done button. You can select the results that you would like to have, and then we can combine the before or the two channels together. And if you want, you can then further explore it in the twin slicer or surface renderer, whatever you would like to do. So this is in a short overview the changes that we made in the Deconvolution Wizard. In April, so next month, we will have a new extensive workshop about all the aspects regarding the Huygens software. So if you are interested in more information about this, I would recommend to sign up for this workshop. It will last for 2 days, or mainly this time it's aimed for the Americas market. So that's so we will here in Europe will be here in the evening, just presenting you all kinds of stuff about background information about the Huygens software, everything about visualization and analysis tools. So again, feel free to sign up for that. And with this, I would like to conclude this webinar, and thank you very much for your attention. If you have questions, please send an email to support@svi.nl, and then one of us will get back to you as soon as possible. Thanks again for your time, and have a great day. Thank you. Bye-bye.